All right, guys, so let's start with just a little warm up here. Now, this is review. So I want you to go ahead and use this figure here and then write a congruent statement and also list all the corresponding angles that are congruent and all the corresponding sides that are congruent. So go ahead and do that now and then we'll go over it. All right, this is what you should have gotten. Now notice that if this is in a different order, this will also be in a different order. Just make sure the order of the second matches the order of the first. And then for congruent angles, you should have 5 pairs. And then once again, congruent sides, you should also have 5 pairs. All right, we do have one vocabulary word and then a very important theorem to cover. So the vocabulary word is an included angle. So an included angle is just an angle formed by 2 lines and a common vertex. Okay, so if I have these 2 sides, the included angle would be the angle between those 2 sides, or the angle formed by those 2 sides. That would be the included angle. All right, here's the side angle side congruence theorem. Here it's written side angle side. Usually we just write it SAS. And this is just saying if we know that 2 sides in the included angle of one triangle are congruent to 2 sides in the included angle of the other, then the triangles have to be congruent. So this is kind of what we watched on that short clip. This is a very, very, very big shortcut. So if you remember with the proofs before, we had to show that every single part of the 2 triangles were congruent. So all 3 sides were congruent, and we had to show that all 3 angles. Now we only have to show 3 pieces. We have to show we have 2 sides, so this side and this side, and then this side and this side, and then the included angle. Okay, one common mistake of this is when students don't know the included angle, they just know, I don't know, like say this angle and this angle. That would not work because this isn't the included angle of the 2 known congruent sides. Okay, so it has to be the included angle. All right, so let's go ahead and do a proof. I think you guys will find that you'll really, really like these theorems because they're huge shortcuts. All right, so we're given that BC is congruent to DA. Okay, that's given. And then we're also given that BC is parallel to AD. Okay, so we have this side here and this side here are congruent. Now always ask yourself when you're doing congruent triangle proofs, do they share a side? Well, if you notice, both of the triangles share this CA. So I always put an X on it. And if they do, we're going to use the reflexive property. So CA is congruent to CA. All right. Now, we have 2 sides. We need to know the included angle of those 2 sides. Okay, so if I go back to these 2 lines being parallel, so I have a top and bottom that are parallel, and then I have CA as my transversal. Okay, so what do I know is true about this angle and this angle? Well, these are alternate interior angles, and I know that when the lines are parallel, alternate interior angles are congruent. If you notice, that's this angle right here and this angle right here. So I can conclude that angle BCA is congruent to angle CAD by the alternate interior angle theorem. Okay, so now notice I have a side, I have another side, and then I have the included angle. So that's all I need. Okay, here's one side, here's one side, here's the included angle. So I can go ahead and say that triangle ABC is congruent to triangle CDA by the side angle side theorem. And that's it. So much shorter than what we did before. All right, let's look at this proof here. So it says in the diagram, QS and RP pass through the center M of the circle. So we know that M is the center of circle. That's what's given to us. Okay, we want to conclude that these two triangles are congruent. All right, well, let's look at this. If this is the center, wouldn't that mean that MS and MQ are congruent? Because aren't all radii of the same circle congruent? So I can just write radii of same circle are congruent. Okay, that's the definition of a circle, guys. Every point from the center to the outside, anywhere you go, it's going to be congruent. Likewise, I can say that about MR and MP. So MR is congruent to MP by the same reason. Okay, so I've showed that two sides are congruent. Now, if I look at these angles, I do see that we have a pair of vertical angles. That should start jumping out at you guys. So this angle here and this angle here are vertical angles. And if you remember, the vertical angle congruence theorem tells us that vertical angles are congruent. So I could say angle SMR is congruent to angle PMQ by the vertical angle congruence theorem. Okay, now I know two sides and the included angle, and that is all I need. So I can say MRS is congruent to triangle MPQ by the side angle side theorem. All right, I'm going to get you guys started, and then I want you to try to do this one on your own. So we're given this picture of this barn here, and it says you're making a canvas sign to hang on a triangle portion of the barn shown in the picture. You think you use two identical triangular sheets of canvas. You know that RP is perpendicular to QS. That's one of the things it's given. And that PQ is congruent to PS. That is also given. It says use the side angle side congruence theorem to prove that these two triangles are congruent. Okay, so I'm going to give you a minute to try to get this one on your own, and then we'll go over it. All right, so let's look at this. Hopefully you're able to figure it out. If I go back to this here, if they are perpendicular, that means that they cross at a 90-degree angle. So I can say that, go up a little bit, angle RPS and angle RPQ are right angles. And that's just by definition of perpendicular. Okay, well, if I know they're both right angles, that tells me that they are congruent. So angle RPS is congruent to angle RPQ by the right angle congruence theorem. All right angles are congruent. That's what the right angle congruence theorem tells us. So we have a 90-degree angle here, 90-degree angle here. I've said that this piece and this piece are congruent. Now you need to ask yourself, do they share a side? RP, guys. RP is both part of the left triangle and the right triangle. So I'm going to use that to our advantage. Okay, so I'm going to say that RP is congruent to RP by the reflexive property. Okay, well now side angle side, side angle side. Now I can say that triangle PQR is congruent to triangle PSR by the side angle side congruence theorem. All right, guys, this is our last one. Once again, I want you to try to do this one on your own. So go ahead, read the words, pull out what's given, pull out what you're trying to prove, and then try to write it out, and then we will go over it. All right, so we're trying to prove that triangle DRA, so I'm just going to come right here and draw this right here. Triangle DRA is congruent to DRG. Okay, so it says you design a window so that, here's my given, DA is congruent to DG And when I write that, I'm going to mark it. So DA and DG. And we're also given that angle ADR is congruent to angle GDR. So ADR, so this right here is congruent to GDR. So this and this are congruent. Okay, well, I have a side, I have an angle, I need another side. But if I look at this, I see that both triangles contain this side right here, DR. So I'm going to use the reflexive property. DR is congruent to DR. It's reflexive. And guys, these two are given. And after I have that, here's my second side. So then I could just say that triangle DRA is congruent to triangle DRG by the side angle side congruence theorem.